Hello and welcome to this presentation of our new function in pre-stress that we call flexible support. It's a new calculation of the cross-section utilization for hollow cores. Because of the deformation of the beam when applying loads, the cross-section of the concrete will get internal stresses due to the restraints. This is described in FIB Bulletin 6 and the upcoming EN 1168 plus A4, and we will soon also implement the calculations according to the Finnish Code Card 18. The loads are considered in flexible support in two different loading stages. We have the construction site and we have the finished building. And if the structure has a topping, the topping will in the construction phase be considered as a load without any stiffness, and in the later stage it will be a proper topping with stiffness as well. We have released this function as an internet browser powered user interface, and it is available for Google Chrome, Mozilla Firefox, Microsoft Internet Explorer 11, Microsoft Edge, and many other internet browsers. And here we can see the user interface. I will now have a short presentation of the program. This is the user interface that is available from the Tools menu in the new release of Pre-Stress 6.5.007. Here it is possible to use hollow cores. There are a few predefined, but it's also possible to define your own hollow cores. And the hollow cores can be imported from a DXF file, and it's possible to change the geometry and add a strand pattern in order to get the correct reinforcement. We enter the material, the pre-stressing force and the anchorage length. It's possible to also have the span width of the hollow cores different for both sides, and it's possible to have different loads on each side, and you enter the load excluding the dead load and the dead load of the topping. It's possible to have different support positions on the beam. As we can see for this flange beam, it's possible to have it on a lower position or the upper position. I will use the lower position for this presentation. If you have a topping on the hollow cores, you can enable the topping. You can change the height of the topping, and if it's a structural topping, then you want to add the interaction and then the possibility to change the material of the topping. If you want reinforcement in the topping, it is also available to enter here. The beams that we have is flange beams, normal beams, I-beams, steel beams of different sorts, even though they are not really looking good in this example. It's possible to add them here. For this example, I will use the flange beam. You enter the material of the flange beam, and you enter the distance between the moment 0 points. The support of the hollow cores on the flanges is entered here, so I enter 100 millimeters. The connection between the hollow cores, if it is an interacting joint, if you want to have reinforcement bars above the center of gravity, or if you want this cut off end of the hollow cores. The calculations that we have are the standard Eurocode, but we also have the national annex from the United Kingdom, from Sweden, Denmark, Norway, Finland, and if you want to use a national annex or just a custom settings of any other country, you can enter those as well. For this example, I will use the standard calculation. When you have entered all the in data, you press Run Calculation, and we see the stresses and the utilization of the hollow core of both the ultimate limit state and the serviceability limit state, where the curvature of the beam is more important. We have in this 3D window possibility to either see how the slab looks like in 3D. We have the possibility to look at a section, or only to see the hollow core and the hollow core section, or to look at 1 meter slab of the hollow core and to rotate and in order to see the strand pattern. And when you have done your calculations, it's possible to get a print report here as well. And this print report states all the information that's needed, and you get a few pictures as well.